Hi, welcome to Python Bootcamp. So in terms of the setup for the Jupyter Notebooks, this is the default. And once you launch it, you'll get okay, well, for me, it's an error because I think I left this on way too long. So let me try again. And hopefully it doesn't produce an error. Okay. Well, so effectively, you'll come up with essentially a directory that says these are the files in your home directory, and you should be able to click on Python Bootcamp 2021. There's two Python notebooks in there. One will say original. Don't click on that one. Click on the one that just says Python Bootcamp 2021, and it'll look something like this. Minus the workshop account password. So, hi, I'm Marcelina. I'm one of the software team members, part of the RCC, the Research Computing Center, and we're down in the basement of Dirac. And helping me today, as we kind of shift through different topics, it'll be me, Alex, and Prasad as presenting, and then of course we'll shift around and also be your moderators. Casey and Paul are also here to help out and moderate. So got a whole team of RCC members. So to get started, I just wanted to do an overview of all the different sessions that we'll be covering today. We'll be kind of installing, I'll give you example code for how to install Python on your own account, which we won't be doing today. This is just kind of like in case you'd like to do this offline or outside of this boot camp, here's some code. There's also a lot of documentation online, and we'll point you in the right direction. So what you'll be doing is accessing Jupyter Notebook via Open On Demand. And there's a way, of course, if you already have Anaconda Navigator, you know that it's already installed on your computer, but there's specific ways to go about installing Jupyter Notebooks. And then talking about your basics in terms of like hello world and the different data types that are available in Python, and just a general history overview of Python is what my session will be covering for session 1. Session 2 will get a little bit more into different loops, conditional statements, and functions. Session 3 will go into a more complicated version of Python Hello World, so with print statements, read writing, errors, exception handling, and then 4 is a little bit of, I guess, real world experience, which is a bit more advanced and definitely to inspire you guys to continue learning about Python. So yeah, I guess, of course, like if you are having any trouble logging in or getting started, please let our online moderators know if you're online. And then if you're in person getting started, like raise your hand and one of our in-person moderators will help. So yeah, specifically for my session, installing Python, how to use pip, install Jupyter Notebook, are just basic overviews of how to do that. We won't be doing that in this session, but there's code for you. And then your basic Python Hello World and all of the basic data types, as well as what are for loops and conditional logic in Python. So as part of this boot camp, there is no necessary Python level of knowledge that you're supposed to know coming into it. You can be a complete newbie or have programmed a little bit and just want to learn a little bit more about Python. So I'll go into actually what Python is in terms of a programming language. It's a high-level programming language. It essentially turns a computer language into something more understandable for humans, and is less typically computer-oriented language. So as we scroll down, we'll kind of see like that it is simplified, and you can kind of For those of you that are familiar with programming, it looks kind of like pseudocode, but it'll still run as Python code. It focuses on the usability versus optimal program efficiency. Python is an interpretive programming language, which means it does not have to be compiled. When I run something on here, it will immediately, it will just immediately run. It does not have to go through a compile step before it runs the program. So let me scroll back up. Python is object-oriented and interactive. So again, the way that we can just have code in a Python notebook and not have to compile it, but also be able to fix and debug errors immediately upon receiving the output, if it's incorrect or if you get an error, is part of that interactive aspect of Python. And it's object-oriented because the variables itself contain both data and methods or functions, which is not common for all programming languages. So it's especially important that like Python itself is object-oriented, and we'll go a little bit more into that when we talk about specific data types. A benefit of Python, it has various open source libraries available. It actually has 355,000 projects on the Python package index. And packages are also essentially like packages and libraries are groups of functions and methods and data types that all come in like a package. So when you import these packages, you can use everything that's inside of them. Yeah, so in terms of different versions, right now the current version of Python is 3.10. And why that's important is that between Python 2 and Python 3, there are a lot of differences. So something that you, some program that you write in Python 3 cannot actually be run and produce the same output in the same way as a program in Python 2. So there are differences in syntax, and there are differences in like what happens when you divide integers, storing strings. There are basically a lot of different differences. There are a lot of distinct differences between Python 2 and Python 3, especially just in the coding aspect of it. So something that you code for Python 2 cannot be run in Python 3 and produce the same output, and vice versa. So that's why it's important when you have a Python notebook or even your installation of Python that you make sure that you know which Python version you're installing, and that way you are coding it for that specific Python language. So Open On Demand is run through the RCC, and so it has only version 3.6. But the current version, if you were to install it on your home computer or your local computer, it would be 3.10. And there are like minor bug fixes in between like the different point values, but it's not as drastic of a difference between Python 2 and Python 3.
Can you go show the actual setup page on Jupyter again?
Okay. Sure, I can do that. So sorry for, we're just gonna go back and look at the setup for the workshops real quick, just to jump. And then again, if anyone has any questions, please raise your hand. Or if you're online, please let one of our online moderators know, and they're working really hard to get everyone set up and going. So Open On Demand. ood.rcc.fsu.edu, and that's loading. Yeah, so while it's loading, does anyone have any questions? I guess like who all, like in terms of experience, is it a lot of like everyone is an expert at Python and just needs a review? Is that okay? So I'm assuming somewhere in between and like knows a little bit, or maybe doesn't know it a lot, but hopefully we'll change that by the end of the session. It's a lot of information to get through, but we'll be together for like approximately like 8 hours, so we'll learn stuff. I am slowly loading. I don't know if is that an issue. Yeah.
Quick question.
Sure.
I know you were talking about how Python doesn't need compilation and run. How does it handle the errors on runtime?
So we'll get a little bit into that in session 3, where we'll talk specifically about the different errors. For those of you that are online, an in-person attendee asked how does Python handle errors if it's not compiled, right? Okay. So there are actually, so Python can be both compiled and not compiled depending on what you want to run. But I guess the key takeaway is that it doesn't have to be compiled, but both either the compiled or the interpreted version has errors and kind of produces that in like very bold red text. So you'll definitely see that it's an error. Of course. Okay. Alex, you still need me to run the. Okay. Then in that case, I'll move forward. Excuse me. With the different uses of Python, this is pretty varied across all different fields. But essentially, there's different libraries pertaining to each of these that are all accessible via the Python package index and also in default Python standard library. You'll have access to libraries and packages that'll help with each of these types of application. A big part of Python, what I mentioned before, is that it is a high-level programming language. So it's a very big, I think like it's very simplistic language as opposed to other programming languages and not very syntactically heavy. So it's very good for education purposes and like just building blocks of coding. Yeah, and in terms of desktop applications too, like Python can produce a graphical user interface that you can work with and to complete like background application processes. So yeah, in terms of, in terms of programming, you can actually just create Python code on a either Notepad or text editor, because it's effectively like just you just save it as a .py script, and then you'd be able to run it. But there are specific Python integrated development environments, IDEs, and they specifically are used for that, like, you know, runtime error, debugging, and in terms of like other programming languages, they also have their own specific IDEs. So if you hear that word thrown around, like it's basically just a software application that is specifically to help you run the programs and kind of debug, where it even says like line by line, like, oh, this is where your error might be, like this is where we're running into an error. Idle is installed when you install Python for the first time. Anaconda installs Jupyter and Spider already into it, and they all have their own different features. So in terms of Jupyter, Jupyter is this notebook. It's a Python Jupyter notebook. And effectively, you can have a mix of images and text along with coding blocks, which is something you couldn't do if you were to have it in just a text editor. And so, yeah, we actually also have a smaller workshop specifically for using Jupyter Notebook. So if that interests you, they'll focus more on like Anaconda specific Python things in that workshop. And I think it's on March 8th. And that'll be held in this room as well. So just to plug. And then yes, to go back to the Python libraries, it's essentially, yeah, so the Python packaging index has 355,000 different projects and definitely more releases than that of like updates and upgrades to these projects. And you can essentially just download them from the internet if you find that they're super useful. We'll actually go into one because there's a specific data type that only appears in one Python library. So in terms of installing packages on your main computer and also on the bootcamp environment that we've created for you guys in your workshop accounts, it would be something akin to here, a pip install. And a lot of this is listed on our website documentation. So yeah, so if you find it online in terms of like the package that you want, you can find them at either of these locations. And this is just kind of the syntax that you're looking for. Since I'm here, I can kind of explain in terms of how code, like the code syntax, if you put a hashtag or a pound sign in front of anything in Python, it's read as a comment. So the computer won't read it, but it's free to read for human eyes. But essentially, it's for comments and stuff. It's to keep notes on like what's happening with this code, because on lots of different occasions when you're programming, just in general, you can program a very long program, and if you look at it like a week or so afterwards, you're like, I don't know what this was doing and what do these things mean. So commenting is very important in terms of like keeping track of like what's happening and what location, especially moving forward and like coming back to code and running it again. So specifically, this is specifically commands for our system because it's Python 3.6, but I assume that if you are installing things via 3.10, you would just change this from 3.6 to 3.10. And these commands also differ whether you're programming on a Mac or a Linux computer versus a Windows computer. So Mac or Linux is going to be a Unix-like system, and then for a Windows system, this is how you would run it. And like you all have access to this document, and if not, we'll send one out later in an email. So you have that handy in case you choose to install things locally. And then when you go to install things, I would just remove this whole thing. Don't keep the brackets. This is just a way to kind of signal that this field is changeable. And this should be changed when you choose to install whatever package you are looking for. So for example, this is an example of how to install Jupyter Lab specifically on your computer. And then to run it from the terminal, you would just type in Jupyter Space Lab. And it should pop up with what you guys see either on Open On Demand or on the My FSU VLabs where it has that directory, and you could just click on the Python notebooks. Okay, so so these are just notes again on getting started on the HPC. If you have your own account, you would log in like this via the terminal. You can change your username to the workshop account, and that would be how you log in from the terminal. And you have to be on either FSD Wi-Fi or on campus, or using the VPN. And this is effectively code on how we set up the bootcamp environment that everyone is in right now and looking at. We load in the Python 3 module, and we create the virtual environment. And instead of my app, it was bootcamp v-env. And that's how you run it from the terminal. So this is all a lot of code. All the code that I've talked about up until now has been stuff that like you don't necessarily run, and it's just for future reference. So we were planning on taking a break at 10:30. So I think I'll field questions first before I go into basic data types. And then if there are no questions, we'll go directly into basic data types and see how far we get to before our first break. Online moderators, are there any questions? Okay, so online is working on setup still. So I might save basic data types for a little bit later. Does anyone in person have any questions? Okay. All right, so yes, no. I'll jump into a basic overview of basic data types then, and go just very slowly, so that way if anyone has any questions, they can let me know. So in terms of basic data types, there's four specifically that four types that I wanted to focus on for this session. There's text types, there's numeric types, sequential types, and the Boolean type. Sequential types and Boolean types will kind of lead us into talking about for loops and conditional logic. But for now, they're also very simple, and let me know if I need to slow down, because this is also a lot of information. Okay, so for text types, that would typically be your string variables. And you can typically see them denoted as letters or phrases in double quotation marks. Double quotation marks. So for example, this in and of itself is a string. So when you print a string, it will not print the double quotation marks, because you're only printing the data that it contains, which is hello world. Oops. And so print is also a built-in function, so you don't actually have to import any new packages, any of the libraries that I was mentioning before. You can just print off the get-go. So if we were to, oops, let's see, scroll back. I guess even just to run this. So if I were to type in Python Bootcamp 2022. Oh goodness, I did have 2021 on there, yikes. All right, so if I run this, and the way that you run things on Python Notebook or Jupyter Notebook is you can either press this play button, which will run it. You can also do if you're in the code block, Shift Enter will run it as well. And then I believe there's one up here or down here. Run the focus cell. which they'll do the same thing. And for this is only print statements, but later on we'll see what happens when it's not a print statement, or if there are multiple print statements listed. So as a string text type, you can actually check the type of variable by doing type open parentheses, close parentheses around the string, or this is actually around any variable or data type. So once you do that, it'll output class and then whatever class it is, or whatever data type it is. So for this one, I don't know if you can see it online because it might be super tiny, but viewing on your own screen, it says class str, which is the Python representation for string. So in addition to just checking the type of just data existing in Python, you can also store things into variables. And the cool thing about variables in Python, if you know any other programming languages, you typically have to state like, oh, this variable is a integer, or it's a decimal point, or it's a string, or it's a character before you give it a value. But since Python is an object-oriented language, you can just set it to anything. So X can be 1, X can be hello world, X can be Python Bootcamp 2022, and you don't have to say like that X is a particular value. But once it has a value inside of it, it is specifically that type. So for example, this has X equals 1, and I can check specifically what type X is, and it gives me an integer. And an integer is a whole number. I guess the easiest way to separate it is if you don't see a decimal point, it's a whole number. So no fractions, no decimals, whole numbers are your integers, and that's just one of the numeric types. The numeric types are integers, floats, and complex numbers. Looking down on looking at the next couple of code blocks, it's actually the type function actually can tell the difference between all three. So you'll actually see that if you run the type command. So your floats, so integers are your whole numbers. Your floats are your decimal places. So anything that has a decimal place is what you would consider a float, and your complex values are the ones that have like your i's or your j's. So anything in that realm is considered not a string but a complex type. If you'll note, the strings are the only ones that have double quotation marks. For the numeric values, you can just set the number to it, and it is able to, let's say, even if I wanted to print X, it would print 1. So it wouldn't print the variable itself, it would print the value, the data that the variable holds. So I guess a little more complicated in terms of the numeric type. If you add a integer to a float, it automatically becomes a float because it has a decimal point. And so that's kind of what I'm depicting here. The type of 1 plus 2.5 will obviously be 3.5, but it would be, in terms of data types, it would be adding an integer to a float. So that will actually produce a float class. And then of course for complex, if you're adding anything to a complex value, it still ends up being complex. So 2 plus is still complex. Does anyone have any questions on numeric types and or string types before I go on further? Yes.
You got two float types, 1.5 plus 1.5.
Right.
The 3, that becomes an integer, or it stays at 3.0?
Yeah, so it'll stay. So the question was, if you add together two float values and it equals a whole number, does it immediately become an integer? And the answer to that is no, it stays a float value because actually then when you print it out, we'll actually do it here. So 1.5, right, plus 2.5. So we'll print what it is and then what the value is. So once you run it, it's still class float, and the value itself is 4.0. So there are actually specific functions, just like type, that will allow you to change float numbers back to integer types, but you have to specifically set it. Once it's a float, and if you just kind of like add different numbers to it, it'll still like stay a float. Yeah. So any more questions? Yes. So complex variables or complex numbers are the ones that have it multiplied by like the square root of -1. So like that's an imaginary number, and like that would be considered like a complex number. Yeah. Any more questions? And then I guess in terms of online moderators, do we have any questions? Okay, perfect. Okay, so we have 5 minutes. I will talk about this sequence type, and then that'll lead us up to talking about arrays in the next section. So there's a couple different sequence types. There's lists, ranges, arrays, and tuples. And for a list, it can be, lists are crazy. So essentially, like, I have these list of numbers right here, and those are denoted by the square brackets next to them on the outside of all of the values in this list. And for this list, I have y equals a list that has 1, 2, 3, 4, 5. And as you can see, when I try and add another list of that same size, it just adds those numbers at the end. And you can do add even if like the rest of these items are, or even just one of these items are like items on your shopping list. It will still, well, slowly, it'll still produce like a giant list because lists don't need to have a particular type. Like they all don't have to be the same type in this list. So you can have integers and floats and complex numbers and strings depending on what you wanted to do with your list. And then it still kind of has that feature of adding and subtracting, and you may get an error, but a lot of it is it's like a very funky collection of values. So what we'll do actually next, I'll like start a little bit with what arrays are. So I guess the big thing is, what if you do want to add one list to another and add those values together? You can't necessarily do it with lists, but there's such a thing as an array type. That's specifically part of the NumPy package. So it's not part of the standard Python library, but you are able to add each individual item to itself. But obviously with limitations, because you can't add, say, carrots to 1, and that's why that doesn't really do it in terms of a list. But for arrays, you can only have a numeric data type within that list. So let's, and this shows a little bit of like the difference between creating lists and creating arrays. So in terms of this, it would be putting a list into np.array, which then creates an array from the list, and the list also has to have all of the values as numbers. So if I were to put carrots in here, it will give me an error. So to point to your question earlier, this is how Python handles errors during runtime and not through the compilation process. So yeah, so we'll change that back. And yeah, so if we run this properly, we are able to print the array and then print the type of the array and then add the array to a NumPy array of the same values, and that produces a NumPy array with 5 values, and they're just doubled because we added the same array to itself. So instead of 1, 2, 3, 4, 5, it has the values of 2, 4, 6, 8, 10. Yes.
Is it possible to have an array of strings?
It is, but you won't be able to do mathematical computations on them. Yeah, so that's what produced the error before. And let's see. So I guess to dive a little bit into also the using packages itself. So this imports the NumPy package, which is already installed on this. It's just a way of saying like, hey, I want to use different methods and data types within this package, and I want to use it in this code block. So that's essentially what the import NumPy statement is. And since NumPy is a little bit long, if you put as np at the end, you can use that in the code block to call that package to be like, so in terms of this array function, it's np.array because it's from the NumPy package. So if you were to just put array, it'll give you an error because it's like, I don't know what this array function is and where it's coming from. So that's why we have np dot array, and it works perfectly. So yeah, do we have any questions so far about the different types that we've talked about, or any of the history? And then also, feel free to ask about any concepts that we've talked about thus far, because I know sometimes if things are just confusing, it's like I don't even know how to formulate a question to ask what I want to ask. So just if you're one of our virtual attendees, let our online moderators know. If you're in person, raise your hand, and I'll repeat the question for our virtual attendees. And yeah, so any questions? Yes. So the question is, can you do computational or mathematical computations with lists? No, you can't, because what it'll do, essentially, this is, I guess, a little bit more deep in the Python, but if you just use the add function, it'll just add it to the end. It won't actually do the mathematical computations. And so that's why we're introducing arrays, even though it's a little bit more complicated than your basic data types. Of course. Do you have any other questions, in person or virtual? Yes.
Just going back a little bit further.
Sure.
In your opinion, which would you say is the best text editor for Python?
The best text editor for Python? You mean IDE?
Yeah.
Okay, so I think I really like the Jupyter Notebook for the IDE, because it allows you to have both large text markdown instead of just having to stick to the small comments in code blocks. And there's also an ease of use, and also a lot of like transformability. So you can actually print out this Python notebook as a PDF. You can print it out as slides, or like convert it into slides. So again, like a lot of features that like a typical text editor doesn't have. So yeah, of course. And it's free. Yes. We all love the college life. Everything's free. So any more questions? Anyone online? Okay. All right. So yeah. So if you have any questions online, we have moderators to answer those questions. And then I guess for both sides of things, we're actually going to stop recording, and we're going to take our first break. For those of you that are just joining us online, make sure to reach out to an online moderator to make sure that you get your workshop account where you can view this Python notebook and participate in the practice sessions, or the practice activities. And yeah, so the recording has started for session 2, and I'm just going to continue on from what I've talked about in session 1. And so a little bit of what I talked about in session 1 was a focus on just like what is Python and the different IDEs that you could use to program, and then a little bit of what the basic data types are. And from there, I'll kind of talk a little bit more about a couple different basic data types that are a part of the sequential type that I mentioned before that arrays and lists both belong to. And then a little bit about for loops and conditional logic before we switch presenters. And Prasad will talk about functions and dictionaries and a lot of other things that I don't cover. So more advanced data types, as well as just more learning to code in Python. So, so two other types of sequence types are range and, I guess tuple, which is very similar to a list. So ranges are essentially you list the beginning value of a beginning integer, and then you list up until what stopping point is the, okay, hold on 1 second. Can one of our in-person moderators go grab the charger from upstairs? Thank you. Yeah, it's in, or yeah, downstairs. It's in my office. Yeah. Okay. So barring a crisis. Okay, anyways, sequence types. So range is a specific one that we'll actually be using in the for loop, but essentially it takes in 2 integer values, your start value and then the stopping value, and it'll actually stop right before that stopping value. So if we print all of the values in the range 0 to 6, we'll actually get 0, 1, 2, 3, 4, and 5. So this works for any values that you put in there, and it'll go through them sequentially ascending. And yeah, and you'll typically see this as range, open parentheses, close parentheses, and the 2 numbers with a comma between. And then for Boolean type, this is a very common, this is actually very helpful when it comes to stuff like for loops, and Prasad will actually go into stuff called while loops. And the Boolean type can only be 2 different values. It can either be true or false. Any other value would either be a string or just, it'll give you an error. And for the true and false value of these variables, they have to be capital. If you put them lowercase, they actually won't recognize what that is. And if you're programming in the Python notebook actually will change color. So if you're seeing that blue, then you're doing it right. So typically you use this to, true will do anything if you ask, like, is this value greater than this value, less than, equal to, that kind of stuff. So an example here is we have x from before, x was 1, all the way back when we were doing integers. And statement A is equal to is x less than 5. And so since 1 is less than 5, this will print out true. So x is less than 5 equals true. And so that's this print statement down here. Kind of going back into the formatting of print statements, if you wanted to include the variable, but also include some text, this is a way to combine both a string and a variable. Because if you were to include the variable itself into the string, then it would just print out the name of the variable and not the data within it. And so just make sure when you do this that you do the string in your double quotation marks, and then put a comma and then the variable that you choose to include. And you can actually, kind of put the variables in wherever you want to put them in case you want to add like a string at the end of it. This will still run properly. So wait. So that way it prints out the value of statement A, but then also prints out the rest of the string. And that's how you include variables into print statements. So there's, so I guess to do both the opposite of a true statement, so a false statement, to see a false statement, we did, I used the example of arrays, and we talked about that a little bit before the break. And much like I was talking about, like how Python is object oriented, you can actually pull the size of the array, so like the number of elements in the array, by just doing dot size for the array, because it's already like that method is already attached to that variable. And so you are able to access the size of the array just by pulling that, and you actually don't need to reference NumPy because it's already associated with the array variable. So the number of elements in array, so the number of numbers in the array has 5, and that was like the 2, 4, 6, 8 that we were viewing earlier. Let me scroll back. So this is 2, or actually no, it's 1, 2, 3, 4, because we just added this array to this random array, but we didn't save it in, we didn't save it at all. So if we were to save it, we'd actually have array equals array plus NumPy array, and then you wouldn't see a print statement. But you would be able to view it in array if you just printed it. So now it says 2, 4, 6, 8, 10. So the statement that would produce a false value is if I typed in array size is less than 5, and since the array size is equal to 5, it'll print out false. You can also do equals less than, and that will give you an invalid syntax because it should be like this. And then if you change the array size to be less than or equal to 5, it'll print out true because it is equal to 5. Let's see. So to display all the numbers in, actually, before I go a little bit too far into it, are there any questions about Boolean types and range is, because I kind of went over that a little bit fast and jumped around. Anyone in person have any questions? Okay. Anyone online have any questions? Okay, perfect. Okay, so for loops and conditional logic uses both range, and then conditional logic is a little bit of a continuation of the use of Boolean statements. I used the for loop earlier to show you all of the different values in range. Yes. So the arrangement of the line code does matter. Is there a particular one that they're asking about? Yes. So let's see. Okay, so if we were to set x equal to 7 here, and run this code, x is less than 5 will still equal true because it is run before the x equals 7. And since Python notebooks actually work dynamically, if we were to run this again, it would actually produce false because x is now equal to 7. If we start, like, x equals to 7 is stored into the Python notebook since it's already been run. So we'll just run it again. And now x equals 7, x is no longer less than 5 until we change what the value of x is again. So yes, to answer the question, it does, order does matter. Order does matter, yes. Okay, any more questions from online? Any questions here also? Okay. I'll wait for typing. Anyone? Okay. So yeah, so what the for loop does is essentially it goes until the end of the list. So this for the typical structure of a for loop is for a variable in this list. And since ranges are a sequential type, it essentially goes through it as a list because it has all the different values between 0 and 6, not including 6. So you can put whatever value you like in the middle. Typically, you'll see I because it iterates over. It's your iterator. And then to, I guess, show all of the different what's happening in each of the loops, I printed I as it goes through. And this one as a temporary value, it'll save the last number in here if you try to print I outside of the for loop, but if you run the for loop again, it'll start again from 0 because it's going through that list. Yeah, so this isn't limited to just ranges. You can also do the grocery list that we did before, which I believe is Y. So if I and Y print I, if we run that 1, 2, 3, 4, 5, which we can see if we, oops, goodness gracious. If we go through it here, so print Y. There you go. So this prints Y and then also prints each individual item for Y. So that means you could also do math on this. If you had a list that had like strings in it, it would obviously give you an error. So if you had to do I plus 4.5, then you get a bunch of different numbers. So you can do a lot of different things, and it's for each element in a list or in a sequential type. And then something important to note is that when you're doing loops and if you're doing conditional logic, to signify to both the computer and yourself what's happening inside the for loop and what's happening outside of the for loop is this indentation. So actually, if I type in for I in Y and I press enter, it automatically indents it. So, but if you're editing this on a text editor, it might not indent it for you automatically. So just for readability and for the computer to translate. So for example, say like we just did nothing in the for loop and we did this. So yes, so it'll produce an error that says expecting an indented block for the for loop, which usually this is tab. Sometimes it's a couple of spaces, and then everything is running normally. But it will give you that error if nothing is indented, or even in terms of runtime as well. So if you were to say print I in the for loop, it prints the I plus 4.5 and I and alternates it. Or it, if you take it out, it'll just print the last value in I, which is the last value in the list, instead of printing it. And so sometimes when you're doing, we'll talk a little bit more about like errors, like error handling in a later session, but sometimes you don't get a print error, or sometimes you don't get errors that are explicit. Sometimes you're just like, oh, the output that I want isn't what I was expecting, and you have to change things around to get that expected output. Let's see. So yeah, any questions on for loops, in person or virtual? Okay. Okay. And then I guess another thing to say about the for loops, right now I'm only doing print statements just to show like what's happening in each step of the loop, but you don't necessarily have to have print statements. Sometimes it's just like a computation. So say we're adding I to itself, and at the, oops, okay, so there we go. So if we're adding I to itself, or to I guess, we would do I equals I plus I, and then at the end you would get essentially 1 times 2, 2 times 3, 3 times 4, or sorry, plus, and just have all of the elements in that list added together. So supposedly, or so actually, yeah, we can print I, and then print statements are just really helpful also for error handling as well. So if you don't actually know what's happening in your code, like for example, what I'm doing right now, you can add in print statements to see like actually what the computation is. So, okay. So again, in this, order matters. So it's actually adding this before I print the like addition. So if I were to print I and then add it to itself and then print I again, that actually should give us the computation. So I plus I plus I plus I again, all the way through until we equal 10, and then that is the I that we print outside of the for loop. That's a lot of unnecessary uses of I, but yeah, so that's debugging and testing in a for loop. So yeah, so if no one has any questions, I'll move on to conditional logic really quickly before Prasad starts his section. So same thing applies with conditional logic. If statements and else statements and else if statements all need to be indented to make sure you know what's going on in each different section. And it's like conditional logic and if statements are effectively used if you're going through something of a loop, or if given a specific value, that changes what the output needs to be. So for this one, this is very simple. X, if we were to use X as the age of a person, and we run it through this if statement, it'll actually tell you whether or not you were old enough to get a driver's license, if you're old enough to get a learner's permit, or if you're old enough to drive even. And this is just a very simplified example of an if statement. So if you're using this to achieve a given output based on a condition placed on the original variable, you can set those like Boolean statements that we had talked about before, that are if X is less than whatever condition it needs to apply to. So for this one, to get a driver's license, you have to be older than 16. So this will actually print true or false depending on what the value of X is. So if true, it'll print this statement. If it's not true, then it'll move on to the next statement. Typically, you have, if you want a really simple one, you can do if you don't want it to print out anything else for the rest of it. So, for example, this will only print out X, and it won't print out anything because X does not meet that requirement of being greater than 16. You can put in an else statement if there's only one other condition that needs to be. So if it's greater than 16, print this. If not, then you would have the else statement print that you are not old enough to drive, which is true for this X value. But if you have multiple conditions, if you have more than 2 conditions, you would add in an else if condition, which also else if only specifies a specific Boolean statement that it has to reach, as opposed to else, which is just like a catch-all for like everything that does not apply to the first condition. And else if is like, if it doesn't apply to the first condition, but it does apply to this condition, please do whatever is happening in that else if. In other programming languages, they split up the else and the if, but in Python, they shorten it and have it elif. And so that's what's happening here. And as you can see, I'm using the comment ## that we talked about in the first session to comment out different lines so that the computer doesn't read it, but we can read it, to kind of show like the different examples of like what's happening in an if statement, depending on what lines you have in the if statement. Yeah, so I guess wildly something that you can try, like I guess outside of this class or during the break, like are these practical activities based on the things that we've talked about previously in session 1. And you can even, what often happens is the for loops and the conditional statements are combined together so that given any element, so I, in the list, you can apply this, you can apply the if statements depending on what the value is. So again, if you're going through a list of different ages, these print statements can kind of say like whether or not this given age is old enough to get a driver's license, learner's permit, or is not able to drive at all. And these obviously are not limited to print statements. You can also do different computations and get different numbers depending. So for example, if you wanted to do computations on only even numbers, you would say like if x is x divided by 2 equals 0, or like is x divided by 2, or like remainder 2, that kind of stuff. But yeah, you can split up the like if for even numbers, else for odd numbers, that kind of thing, within a for loop, and print only even numbers. So yeah, so I've run over my time a little bit, but so these practical activities are based on session 1 and a little bit of session 2. And you guys can go through these at home on your own, and let us know if you have questions later on. And you can actually do these in, if you're looking at the Python notebook, you can do these in that section, and type out like what you want to do, that kind of thing. So yeah, and yeah, so the 2 practical activities are write a program to print all the items in a list using a for loop. And we've kind of already done this, but now this is a different list. So just try your hand at that. And then the second activity is write a program to test whether an item in a list is an integer. And we kind of learned when we were talking about data types, what the function type produces. And so you can actually do like a Boolean statement to say like, okay, like, and use both the type function and like for loops to do this coding block.